Okay, guys, so this is going to be another fun video about chain rule, and this time we actually have two independent variables. So let me first explain the idea. So here we've got z that depends on two variables, x and y, okay? And then x itself also depends on two variables, so that would be u and v. And same thing here with y, also u and v. So when you follow the trees, follow the branches. So first you're gonna start with, let's say you're trying to take the derivative with respect to u. So you're gonna go like that and then like this, right? That's how you can get to u. And then also you can go like this and like that. Okay, so we can say that the partial derivative of z with respect to u would be, so this one would be partial of z with respect to x, and then this one would be partial of x with respect to u, and they're partials because there are multiple variables there. So this is also partial, and this is also partial. Okay, now with respect to v, we also have to add over here partial of x with respect to v, and then here partial of y with respect to v. So if we wanted to find the derivative with respect to v, we would have to follow the v branches, right? So we're going to have to go like this and then like that, and then like this and like that. Okay, so there is your chain rule of two variables. Okay, so we're going to have dz dx dx du, and then plus dz dy, and then dy du. Now we're going to have exact same thing, but with v. So just take the original, whatever you just had, and switch u to v, and then that's how you get the other one. Dy dv. Okay. So that's the rule, but now let's go ahead and see if we can find all of this stuff. We do have to simplify the first two partials, and it says we have to simplify the final answer. Ooh, okay. Well, let's go with the first one. So we are taking the derivative of 3x minus y divided by x plus 4y. We are taking the derivative of that with respect to x. So to do that, you're gonna have to use the quotient rule. And quotient rule says you gotta square the bottom. Okay, that's the first step. Then you're going to take the derivative of the top with respect to x. So think of only terms that have x, and the other ones will drop out. So 3x, that's 3. And multiply that by the bottom, no change. Minus derivative of the bottom with respect to x, which is just 1, right? Because 4y doesn't have an x. Multiplied by the top with no change. And they do want us to simplify. So we're going to have that x plus 4y squared. Never try to cancel over here, even though it looks like there's the same variable, like x plus 4y, x plus 4y, the same expression. It cannot be canceled because the other one doesn't have it. Okay, so you can't cancel like that. What you can do is start distributing the 3. So you're going to get 3x plus 12y minus 3x, and then plus y. So here I can cancel 3x, subtract 3x, that's just going to give me 0. So this will give me 13y divided by that x plus 4y squared. Okay, so this is a very long problem, which does not make me feel very good, but I'm going to submit this just to make sure. Okay, so this part's correct, because I mess up somewhere and then you're like, oh my god, I have to redo the whole thing. Okay, so here we're going to have 3x minus y divided by x plus 4y, and this time with respect to y. So again, another fun quotient rule, which is going to be x plus 4y squared, right? And then now we're taking the derivative of the top with respect to y, which is -1, right? Because 3x doesn't have a y, so it's going to drop out. And derivative of -y with respect to y is -1. Okay, so multiply that by the bottom with no change. And then minus derivative of the bottom, which is 4, multiplied by the top with no change. So hopefully you understand that x will go away because it doesn't have a y, and derivative of 4y is 4. And again, we cannot do anything with that bottom. We have to leave it. So it's going to be x plus 4y squared. on the top, let's distribute that negative. So we're going to get negative x minus 4y minus 12x plus 4y. So you can see that something happening here, right? The negative 4y, positive 4y cancels out. And then we're going to get negative 13x divided by x plus 4y squared. Okay, so let's just hope that that's correct. All right, that is correct. Now let's take a look at e to the power, whoops, it's not supposed to be red, e to the power u cosine v. I am trying to take the derivative of that with respect to u, partial derivative with respect to u. Okay, so here you have to be very careful. Now, you have a product, right? E to the power u and cosine v. But only one of these terms has u in it. So you may be tempted to say, oh, well, cosine v will just drop out because it doesn't have a u. No, not so fast, because this is not addition. We're not adding a term that doesn't have a u. We're actually multiplying by a term that doesn't have a u. So cosine v in this case is a constant multiple that you must keep. You do not need product rule here. Why not? Like, well, some of you may be like, well, I'm just going to use product rule. You don't need it. You can use it, but you don't need it because cosine v doesn't have a u. It's like a multiple. It's like a 5. You just keep it, okay? You don't need a separate product rule. And besides that, cosine v with respect to u, derivative would be 0, so you'll get the same thing. So anyway, but what the important part is that if you have a product of two things and only one of them has the variable with respect to which you're taking the derivative of, the other term is going to stay. It's not going to go away. It's going to be exactly the same. Cosine v, because it's a constant multiple. Derivative of e to the power u is e to the power u with respect to u. So that's what I got there. Okay, so this is going to be the same. Exact same that what it was. Okay, now let's take that, and now with respect to v. So here the same idea, e to the power u does not have a v, so it's like a constant multiple that you keep. It's just a number because u is a number, so e to the power u is a number, you keep it. Derivative of cosine is negative sign. Now never put a negative between over here because it will look like it's subtracted. It's not correct. You want to put the negative in the front if you don't want to worry about all sorts of various parentheses that could also save. You just put the negative in the front. Okay, now let's take the derivative of e to the power u sine v with respect to u first. So e to the power u will stay, and just like I told you, sine v is going to stay. No change. So e to the power u sine v. Now, what about with respect to v? So again, e to the power u will stay, and derivative of sine is cosine. So e to the power u is like a constant multiple. There it is. So this is going to be e to the power u cosine v. Okay, well, the fun begins now when we start multiplying them and finding the partials. So let's first take derivative of z with respect to x. So, oh, sorry, with respect to u. I'm sorry, with respect to u. So that's going to be dz with respect to x, right? Dz with, actually, let me start substituting already into the formula. I showed you, like, right, the branches and all that stuff. So I'm just using this right here. Okay, so this is going to be dz with respect to x. So it's going to be 13y divided by x plus 4y squared. Okay, we're going to multiply that by dx with respect to u, which we got e to the u cosine v. Okay, then plus the other derivative, so actually minus. So this is because it's a negative. Negative 13x over x plus 4y squared. Multiply that by the derivative of y with respect to u, which is e to the u sine v. Okay, so just make sure you understand that which one am I multiplying. Like when I'm doing u, I'm going to multiply this by this, and then I'm going to multiply, because I want with respect to use this guy by this guy. Okay, actually I should make them different colors. So this is going to be like this and this. Okay, that's what I did. Okay, so now let's see what happens next. So now we're gonna do exact same thing, but with respect to v. So all you have to do is just basically switch, right? So this one is gonna stay the same, but this part is gonna be with respect to v. So that's gonna be e to the u sine v, but it was negative. So I'll just stick the negative over here. And then it's going to be minus 13x divided by x plus 4y squared. And I multiply that by e to the u cosine v. Cosine v. Whew, my goodness, that's so much fun. I just can't imagine. Okay, so next, what you have to do, let's actually gonna simplify the first one. Okay, so I am going to go from here over here, and I'm gonna simplify this. So what do I mean by simplify? That's not much to simplify here. If we just cannot leave the x and y in there, okay? So we're gonna get 13, instead of y, we're gonna plug in what it is, which is e to the u sine v, right? And then we multiplying that by another e to the u cosine v. Okay, and dividing that by x, which is e to the u cosine v, plus 4y e to the u sine v. And then we're squaring that. Okay, minus. So it's going to be exact same bottom, by the way, which is going to help us because we can combine this thing into one lone fraction in a second, because the bottom is the same. So when you have two fractions with the same denominator, you can just do the operation on the top. So this is going to be 13x, and x is e to the u cosine v multiplied by e to the u sine v. Okay, so we can see that the bottoms are the same. And looky here, these two terms are the same. E to the u cosine v, sine v. Oh my God, do they just cancel out and this is 0? Oh my goodness. Oh, wow. Wow, that is amazing. Okay, now let's do the other one. And if that one is 0, I'm gonna eat my hat, except I don't have one. Okay, so this is gonna be negative 13y e to the u sine v multiplied by e to the u sine v. Okay, divide that by that whole thing, e to the u cosine v plus 4 e to the u sine v. Square that. Okay. And then we have minus 13x, and x was e to the u cosine v. And then multiply that by e to the u cosine v. And the bottom is the same. So that bottom will be the same. E to the u cosine v plus e to the u sine v squared. And actually, I'm missing a 4 in here. Okay, so when we combine these two, because the bottoms are the same, we can just do the operation on the top. And so the bottom is going to stay and there is nothing you can do about it. Okay, do not try to, God forbid, FOIL it or whatever, or distribute the square, which is even worse. Okay, so here we have, if you look at it, this is going to be sine squared and this is going to be cosine squared. But there is something that they share, okay? So they share this negative 13, and they also share e to the u, right? And another e to the u. So we can factor that out. So we're going to get negative 13. So e to the u multiplied by another e to the u is, you add the powers if you know the rules of exponents. So this is actually going to be 2u. And then if you factor it out, you're going to get sine squared v plus cosine squared v. So remember, we took out the negative. So then that's going to be a plus, right? But everybody knows that sine squared v plus cosine squared v, this is your first trigonometric identity. This is actually 1. So this is my final answer. And hopefully it is also correct. I guess we're going to see in a second. And then that whole thing is squared.